Alright, so in this video we're going to talk about simplifying radical expressions, and particularly ones that do not come out to be necessarily a quote-unquote pretty number. So let's look at the square root of 24. So we've simplified square root of 24 before. We did this when we talked about quadratics, and the method that we did previously was probably a little bit different. We looked for perfect squares. So your perfect square numbers that divide into 24. So for example, like 1, 4, 9, 16, 25, 36, etc. And we saw which ones divided into 24 evenly. Well, for here, this would be 4. So the square root of 24, 4 goes into 24 6 times. Well, the square root of 4 is 2. So we would simplify this as 2 square roots of 6. Now we're gonna do it a little bit differently, and either method still works. But sometimes, if it was the cube root or the fourth root or the fifth root, we're not as familiar with the perfect cube root numbers or cube numbers or fourth numbers or fifth numbers as we are with square numbers. So this other method works just the same. So what we're going to do is we're going to factor tree. So two numbers that go into 24. And it doesn't matter which two numbers. We could use 6 and 4. We could use 8 and 3. We can use 2 and 12. I'm going to do, I'll do 8 and 3. And then I could break apart the 8 into 4 and 2. And then I can break apart the 4 into 2 and 2. And what I like to do is cross off the numbers once I break them apart. So, because this is the square root, what we're going to do is circle groups of 2. So I've got a pair of 2's here. Whatever you circle is going to come outside your root. So I circled 2's, so 2 is going to come on the outside. Whatever I didn't circle gets multiplied and it's going to go inside the root. So 2 times 3 is 6. Now what this helps us do is if we had anything other than 2, we could still use this process. We would just be circling groups of 3 of a kind or 4 of a kind or 5 of a kind. So for example, let's try the cube root of 24. All right, so we can still factor tree this the same way. And you can use any numbers. I'm just going to use the same numbers that we used before. However, because there's a cube with it, or a cube root, I'm going to circle groups of 3 of a kind. So I've got a group of 2's that I circled. This comes outside my radical. Whatever we don't circle stays inside. So this is 2 cube roots of 3. All right, so let's try another one. Let's try the cube root of 54x to the 5th. The cube root of 54x to the 5th. So I'm still going to break apart 54. So two numbers that multiply to 54. I'm going to use 9 times 6. And then I can break apart the 9 into 3 and 3. And the 6 into 3 and 2. Now the x to the 5th means I'm going to write out 5 x's. Okay, it's like x times x times x and x times x. Now this is the cube root, so what I'm going to do is circle groups of 3 of a kind. So I've got a group of 3s, and I can also circle a group of x's. So on the outside, I can bring a 3, and I can bring an x, because that's what we circled. On the inside is going to be whatever we didn't circle. So I didn't circle a 2. I'm actually going to start using these colors on there. And I've got 2 x's, which means I didn't circle an x squared. All right. I'm going to have you guys try number 4. So if you guys want to pause the video right now and try number 4 for me. Let's try the 4th root of 405 x to the 10th. So go ahead and pause the video and see if you can get this. All right, go ahead and check your answer. All right. And I want you guys to try number 5 as well. All right, let's do the cube root of 128 x to the 7th. The cube root of 128 x to the 7th. So go ahead and pause the video right now and work this out. All right, go ahead and check the answer that you got. 4x squared, cube root of 2x. Now here we circled 2 groups, so we had to bring 2 2's out. So you can think about this as 2 squared, or if you want, you can think about it as 2 times 2, either way. So whatever you circle, and you bring out your multiplying. Same way, let's see. Back here, when we had a 2 and a 3 left, and we left a 6, okay, whatever's left, you're multiplying. Just like whatever you bring out, you're going to multiply together. And sometimes I get asked, oh, well, here we had 3/4. So technically, yes, we could have circled these 3/4. However, if I'd broken it down into 2 and 64, and broke it down by 2's the whole time, I wouldn't see the 4's at all. So what I like to do is make sure to break it down until they're prime numbers. You can't break it down into any more. You don't need to break it down into 2 and 1 because it's not changing the value. All right, so that's just simplifying them. Let's look now at multiplying. All right, so let's look at number 6. Here we're multiplying 2 square roots of 12x to the 4th y squared times 3 square roots of 15x to the 5th y cubed. So when I multiply, numbers on the outside get multiplied together. So 2 times 3 will give me 6. This will stay the square root. And then I multiply the insides together. So 12 times 15 is 180. Now when I multiply variables, I add their exponents. So x to the 4th times x to the 5th is going to be x to the 9th. Y squared times y to the 3rd is going to be y to the 5th. And now this problem should look just like kind of like the ones that we just did. So we're going to factor tree this. So 2 numbers that multiplied out 180, 12 and 15. Can be any 2 numbers, remember. I can break apart the 15 into a 3 and a 5. And I can break apart the 12 into a 3 and a 4. And then I can break apart the 4 into a 2 and a 2. I also have 9 x's and 6 y's. So I'm going to write out 9 x's and 5 y's, excuse me, 5 y's. Now, I realize some of you guys may be able to do part of this, especially the variable part in your head. That's okay. I'm just showing you a method that'll work every time. Now, because this is the square root, there's like an imaginary 2 here, we're circling groups of 2 of a kind. So I've got a pair of 2's, a pair of 3's, 4 pairs of x's, and 2 pairs of y. So remember, whatever we circle comes outside our root. So we have a 2 times a 3 times an x to the 4th times a y squared. Everything we don't circle stays inside the root. So we have a 5, an x, and a y. Now what makes this a little bit different than what we did in the past is we still have this 6 that's on our outside that we still have to multiply. So the number on the outside should be 6 times 2 times 3, x to the 4th y squared, square root of 5xy. So 6 times 2 is 12, times 3 is 36. So this is 36x to the 4th y squared, square root of 5xy. All right, I'd like you guys to try number 7, so go ahead and pause the video. Or, excuse me, let me write the problem first, then you can pause the video. 3 square roots of 15x to the 5th y to the 3rd times the square root of 20x y cubed. So before you start the problem, this x has an exponent of 1, so when we don't write the 1 as an exponent, that's what it has. So pause the video, try number 7, and see if you can get it. All right, go ahead and check your answer. So you should end up with 30x cubed, y cubed, square root of 3. So the 3 from the outside, 10 from your inside. 3 x's, 3 y's, and a 3 left over. So another type of multiplying that we could see. 3 plus 2 square roots of 5 times 2 plus 5 square roots of 5. So here, because of the addition sign between them, when we multiply these two parentheses together, we have to distribute. So first I'm going to distribute the 3. Okay, 3 times 2 is 6. 3 times 4 square roots of 5. 3 is on the outside of our radical, and 4 is on the outside of the radical, so we multiplied them together. So we have plus 12 square roots of 5. Then we're going to distribute the 2 square roots of 5 to each term. So 2 square roots of 5 times 2 will give us 4 square roots of 5. And 2 square roots of 5 times 4 square roots of 5 will give us plus 8 square roots of 25. Now the square root of 25, we should know this is 5. So this last term really becomes plus 8 times 5, and 8 times 5 is 40. And now I can combine like terms. 6 plus 40 is 46. And 12 square roots of 5 plus 4 square roots of 5 is 16 square roots of 5. And that's our answer. All right, so go ahead and try number 9. Pause the video and see if you can get number 9. Let's go ahead and pause the video and try number 9. All right, check your answers. So go ahead and check your answers. For this one, our radicals happen to cancel out. A negative 12 squared roots of 7 and a positive 12 squared roots of 7 is 0. So we just had the 24 minus 42. All right, let's try adding and subtracting. So the cube root of 250 plus the cube root of 54 minus the cube root of 16. All right, now we cannot add and subtract unless what is inside the radical is the same. So currently, all of these are not the same, so we can't add them. So what we're going to do is we're going to look at each piece individually, and I'm going to simplify each one individually. So 250, two numbers that multiply to 250, 25 and 10. 25 is 5 and 5, and 10 is 5 and 2. And then because this is the cube root, I'm circling groups of 3, so 3 of a kind. So this becomes 5 cube roots of 2 plus, I'm going to do the same thing with my next one. So two numbers that multiply to 54, 9 and 6. 9 is 3 and 3, and 6 is 3 and 2. And again, I'm circling groups of 3. So I circled a 3s, can pull a 3 out. I did not circle the 2, so the 2 stays on the inside. Minus, and then we do the same thing to the last one. So 16 is 4 and 4. 4 is 2 and 2, and 4 is 2 and 2. And then this is the cube root, so we circle 3 of a kind. So I can bring out a 2. And I leave inside a 2. Now when I look at these are all cube roots of 2. So when we combine them, we're just adding and subtracting the numbers on the outside. So I have 5 cube roots of 2 plus 3 cube roots of 2 minus 2. 5 plus 3 minus 2 is 6 cube roots of 2. All right. You guys are going to try number 12. The square root of 12 plus 5 square roots of 75 minus the square root of 3. Okay, so try 12 square root of 12 plus 5 square roots of 75 minus the square root of 3. Go ahead and check your answers. So here, again, square roots are only circling pairs. And our middle term, when we pull out a 5, there's already 5 on the outside, so remember we multiply like we did previously. And our last one we can't simplify, so this is just 1 square root of 3. So 2 plus 25 minus 1 is 26 square roots of 3. Okay, and our last type is dividing, so we're going to look at 2 different dividing types. So the first one we'll do is 7 divided by the square root of 3. Now we cannot have square roots on the denominator, so we need to cancel out this square root of 3 here. So to cancel out this square root of 3, what I'm going to do is I'm going to multiply by the square root of 3. Now, I can't just magically multiply the bottom by the square root of 3. Whatever I do the denominator, I have to do the top. So if I multiply the bottom by the square root of 3, I have to multiply the numerator by the square root of 3 as well. So on the top, I'll have 7 square roots of 3. And on the bottom, square root of 3 times square root of 3 is the square root of 9. Well, hopefully we know the square root of 9. The square root of 9 is just 3, so this is 7 square roots of 3 over 3. And now my square root is on the bottom. I can't simplify anything else, so this will be my answer. Let's go ahead and try number 14. We'll do 5 over the square root of 2. 5 divided by the square root of 2. Pause the video and go ahead and give this a try. All right, you should end up with 5 square roots of 2 over 2. And then there's one last dividing type that we could see. Let's do 4 over 3 minus the square root of 6. Four over 3 minus the square root of 6. So now, instead of having one square root on the bottom, we have 2 terms on the bottom. So I can't just multiply by the square root of 6, because I'd have to distribute and it wouldn't cancel out with the 3. So to cancel this out, we're going to multiply by what we call the conjugate. So the conjugate of 3 minus the square root of 6 will be 3 plus the square root of 6. The conjugate's just the opposite sign between them. So if I multiply that by the bottom, I've got to do that to the top as well. So now I'll multiply these together, and I need to make sure I distribute. So on the top, I'll distribute the 4 to each. So 4 times 3 is 12. And 4 times the square root of 6 is 4 square roots of 6. Now I'll distribute on the bottom, so I've got to distribute both terms. So first I'll distribute the 3 to each. So 3 times 3 is 9. 3 times the square root of 6 is plus 3 square roots of 6. And then I'm distributing this negative square root of 6 to each. So the negative square root of 6 times 3 is negative 3 square roots of 6. And negative square root of 3 times positive square root of 3 is negative square root of 36. So now when I look to simplify this denominator, positive 3 square roots of 6 and negative 3 square roots of 6, these cancel out because one's positive, one's negative. They should always, because we chose our conjugate as the same thing but the opposite sign. So one is giving us negative and one is giving us a positive. Now we still have the square root of 36, but hopefully we realize square root of 36 is just 6. So this last term is really a minus 6. So on the bottom, when I combine like terms, I have 9 minus 6, which is 3. On the top, I have 12 plus 4 square roots of 6. I can't divide either of these by 3, so I can just leave this as this. All right, I want you guys to try number 16. Actually, I changed my mind. We're not going to do this, you try. There's one last type that I didn't get to show you that I wanted to show you. So I'm going to show you right now. So let's look at the square root of 24, x to the 7th, y to the 9th, over 6, x to the 13th, y. Now, while I have a square root on the bottom, first thing I'm going to do is, since I have a square root on the top, I'm going to try and simplify the square root on the top and the bottom first. So when I look at my numbers, 24 and 6, 24 divided by 6 is 4. So this is really a 4. I'll write this in red so we know where that came from. X to the 7th divided by x to the 13th. When we divide by variables, we subtract their exponents. So 7 minus 13 is negative 6. The negative exponent means it goes on the denominator. So I'm going to have x to the 6th on the denominator. And then when I look at the y's, y to the 9th divided by y, this is like y to the 1st. 9 minus 1 is 8. So I have y to the 8th on top. Now this is still all inside the square root, so I need to still take the square root of everything. Square root of 4 is 2. Square root of y to the 8th is y to the 4th. And square root of x to the 6th is x to the 3rd. Right, and that's all for this video for today.